Okay, our next presenter is Vineet Pancholi. He's been at Amkor for several years now and currently leads test technology development for 5G RF and high-speed digital test production test methodologies. Prior to Amkor, he was at Microchip, and prior to that, he spent many years at Intel in a variety of test roles, including test technology development, test supplier management, and RF test architecture. He has a master's degree in physics and electrical engineering from Arizona State University. And with that, Vineet, it's all yours.
Well, thank you very much, Ira, for the introduction. My name is Vineet Pancholi, as Ira said. I'm a senior director with Amkor Technology. And last week, I had this privilege of attending the IMAPS conference, where a large variety of multi-die package technologies and applications were showcased. In fact, this presentation should not bring any surprises to anyone on the bridge right now. All of this content should be well known, especially things that are in fashion, things that are getting too much attention. And Abram's presentation did a very, very fine job of calling out the general themes that the industry needs to be focused on, especially to fuel the future. So, as I said, last week's presentation had examples, and I refer the audience to go look at the IMAPS conference and some of the presentations there. My presentation today is on test impacts of multi-die packages. I will start with integration and markets. I will then talk about assembly package integration technologies and include a handful of Amkor examples. Then I will spend the remainder of the slides looking at opportunities for test, impacts to test, and a call for action, pretty much similar like how Abram had, and I'd use different English words to describe the theme, but the theme is between Abram's presentation and mine are similar. Okay, so I start with this slide that you may have seen before from Amkor. Amkor's integration market applications primarily include automotive, health, industrial, with ADAS and sensor products, communications with wired and wireless communication products for various end use cases, AI, networking, computing products for storage, laptops and data center use cases, and then, of course, the consumer products that are all around us at home. Multi-die package products are exploding in all market segments. Some of these examples were showcased in our presentation that my boss, George, did at the last MEPTech Road to Chiplets session in November. So take a look at that presentation as well. It has a few more examples, if you will. Amkor's Mike Kelly, he's pretty popular and makes the rounds into various industry forums and has presented multi-die package technologies. And this slide that I have is from him. These include the various examples that I have on the slide that are substrate-based technologies. There are a couple of examples that we have in the RDL and silicon interposer technologies, and of course, the 3D stacking examples that the industry has been talking about in the recent years as well. And the key message over here is that die disaggregation within multi-die package is allowing for higher levels of integration, which was the theme that we've been talking about at our Testability BKM as well, with Abram chairing the leading the team there. This slide over here has examples out of Mike Kelly's presentation as well, and I've taken the liberty of adding a couple of annotations. The material type for TSVs, substrates, microbumps, solder, The inner secret sauce of how these are built essentially does impact the electrical performance at test. So we have to always keep that in mind. The next slide showcases silicon photonics. Silicon photonics is an emerging technology that enables high-speed data rates up to and then, of course, greater than 400 gigabits per second in the data center application. And suffice to say that Amkor has a couple of multi-die package variants for silicon photonics. And what we saw in the last couple of slides was that as package complexities are increasing, new matching test methodologies must be architected. And so let's switch gears and talk about production test. Traditional ATE test methodologies are robust to test a single die within the package. This is an example that that we've seen over the past, I want to say, more than 3 to 5 decades of experience that we have. So we know how to do this very, very well. Test methodologies for multi-die packages have matured over the past decade. So these examples, the example that I've built over here is also something that we have seen and tested over the recent years. The complexities of corner cases where die 2 interfaces that are not directly exposed externally have increased by a couple of orders of magnitude within the multi-die package. And that the test methodologies to address testing all new corner cases may need to be developed and deployed into production testing. So these examples where observability, and I think that's one of the themes that you will hear resonate at the event tomorrow, the panel session tomorrow, is gaining traction, is how I see it.
So Vineet, that's a good place to ask a question. I mean, so when a customer brings a design in, are you guys typically able to influence it early enough to get the observability that you think you need, or are they usually set in their ways as to how they want to put it together when they walk in the door?
Very good question, Ira. This is, in some cases, actually, if you talk to the customer, and Amkor being an OSAT, and there are other OSATs as well, I'm sure when I share this sentiment, it's going to be representing a larger OSAT community. But schedule is king. In some cases, there is flexibility where we are able to influence the customer base in terms of what to go focus on and what are the best known methods and what the key learnings are from previous experiences, so we can influence the future. In some other cases where there's a very quick turn to market, that's a separate conversation and needs to be dealt with accordingly.
Thank you.
Okay. Next slide, again, should not be any surprise from a DFT standpoint. Production test methodology and DFT plays a very, very important role. So if I look at the past decade or so, some of the key themes that have come through, functional and structural test methods enable trapping systemic manufacturing failures. And there are a couple of examples of Abram and others within our team that I've been a part of have been talking about BIST, SBFT, SCAN, etc., being some of the methodologies, and I've listed a handful of other more popular IEEE standards that get referenced. Digital test instrumentation on ATEs have matching features that allow for DFT execution. So ATEs are still playing and will continue to play an important role to provide that efficient test content. And then the last bullet on this slide talks about concurrent testing, multitask test execution on ATEs, and matching DFT support on the DUT. So the design must support it, allows for concurrent test content that in the recent years has enabled us with some test time reduction objectives. So that's important. This is primarily the landscape that I see when it comes to. I'm not at least at a high level talks about DFT and importance of DFT in production testing. And really, to be honest with you, the remainder of the theme of my presentation goes into these highlights that I have on DFT. The next slide over here is a functional block diagram straight out of the IEEE 1838 specification and shows the topology where die 1 secondary tap controller is enabling the DFT access for die 2, 3, and 4. So again, a plug for the same theme from 2 slides ago. Now let us look at, sorry for the build over here, but it's important as I work through some of these details as a part of my presentation. Let's now look at the DFT and the interconnect test view of 3D ICs. We start with a functional block representation of an ATE, which typically connects the DUT via the load board and the contactor. And I'm going to skip the load board and the contactor in the interest of simplicity, presentation simplicity. Then we have the package, and this is more of a functional block level. Then we have the package, balls, the substrate, the interposer or interposers in the line of connection. Past that are the die that may originate from different IP vendors and different fab technologies. These die may have digital or analog functional blocks like how I've listed over here with CPUs, GPUs, memories, SerDes, sensors. These were themes out of last week's IMAPs that I captured. These die may have DFT features to enable on-die logic test, and I took the same example from the previous slide with the IEEE 1838. And Amkor brings in, or an OSAT, or the packaging solution over here, Amkor brings in packaging technologies to enable electrical connections between the balls and all of the die shown in this block representation. The challenge for tests is to be able to successfully test the dies along with the package interconnect topology. So in my next slide, I'd like to go into the electrical and thermal test challenges of the same 3-die package topology. Right? So the interconnects that I was showing on the previous slide enable power delivery to all of the die within the package, and that's what I'm showcasing over here with this build. They also enable unidirectional and bidirectional data I/O and clocks. These signals may be single-ended and or differential. These may be narrow, high-speed serial buses like PCIe or broadside memory buses like the high bandwidth memory that we've seen deployed into high volume manufacturing. There may be unique die features that may have dedicated observability pins, and this was the theme from, I think Abram also brought this up, or maybe it was something that we talked about earlier in the last hour at our Testability monthly meeting. And then RF blocks, analog blocks, RF blocks within the package also require shielding from digital and power supply noise. And then at speed operation may generate heat depending on logic layout. As I pointed out in the previous slide, some of these are processor die that may be generating unequal amount of heat, or they may be hotspots, etc. So at speed operation may generate heat, and depending on the logic layout, there may be localized hotspots that may create thermal gradient across the package. And at the test environment must allow adequate thermal conductivity to release this generated heat and allow us to manage the thermal performance of this package. So with all these test challenges that our customer products are presenting, the call for action to the test industry is to design DFX methods that allow production test simplification by developing standardization and enabling reuse. So my theme in terms of my choice of words, like how Abram was using, are standardization and enable reuse and production simplification, test production simplification. DFX methods allow feedback into a package design and test, and by this standardization and simplification, we can accelerate the technology towards maturity, to the same level of maturity that we have for single die within the package. So let's now switch topics and look at how production test flow is getting impacted due to this increase of multi-die functional blocks within the package. This shows the example single chip production test flow, and you've seen this in and you've experienced this in your HVM environment for the past couple of decades. This shows a multi-chip cost optimized high level production test flow. It shows probe die from different wafers packaged into the multi-die package, and then directly going on to the SLT test step and onwards to other test steps as necessary. Earlier in the 7 a.m. hour, Rich and Martin from Advantest had a similar picture to showcase, and I was very, very pleased to see that Ken from Teradyne also had a similar graphics to showcase, where they were showcasing how point number one being the different wafers feeding a single package was the theme, and the other themes are listed over here. There's an altered test flow, the content is getting redistributed, and platform level test quality. Martin did a very good job of in the 7 a.m. meeting talk about the quality metrics and how things are changing at our Testability VKM and Testability IEEE forum that Abram is championing. So shameless plug for our BK, our Abram's team. If you have any interest in this area, please do send us a note, and I would encourage you to join our team to look at these problems and help solve these problems as well at the same time. Okay, my next slide. SOC and SIPs are important. OSATs like Amkor are dealing with SOCs and SIPs every day. These products may bring in a large collection of electrical interface within the single package. Platform level SLT requirements are different than traditional final test and structural test steps. Depending on the implementation of the multi-die functional block, SLT, FT, and ST allow for optimal test coverage, as the slide showcases, in terms of the intersection and the interception of these bubbles. Advanced DFX, and this was the theme in Martin's presentation as well, manufacturing DFX, as in designed for manufacturing, QNR, thermal, and DFT, may need to be created to allow production test simplification. This slide shows a fraction of the off-the-shelf SLT test equipment. Multi-die package floodgates are open. The variety and the number of custom multi-die packages our customers are developing is large. I want to say it's huge. From simple implementations to more complex implementations. Lots of examples in this slide deck and others that you may have recently seen. Custom SLT equipment may result in less than expected factory throughput. And test standardization, again, that plug for test standardization and reuse is expected to help with production test simplification and then achieve that desired factory throughput levels. That's important to all of us, and we should strive to work towards that. Okay, so in summary, multi-die packages allow for denser integration. Test business continues to have an economic and performance challenges. And then, as I said before, there's a test industry call to action to cooperate and develop advanced test methods, like how Abram pointed out in his presentation. I'm sure Samir will have something similar as well to say. The test industry must cooperate to allow us to be competitive and successful in this rapidly growing multi-chip marketplace. I want to say Amkor is the industry leader in advanced packaging and production test solutions. And my next slide is if it would forward, doesn't want to forward, is a slide with a dashboard view of some of the vital fews. And I think that's all what I had for today. I'll take questions now, Ira, if this is a good time.
Thank you, Vineet. You touched upon SLT. Can you elaborate a little bit more on the importance? And then even maybe more importantly, DFT, when you write when the tools generate vectors, they're testing something specific. So when you have a failure, you pretty much know what it means. But SLT, how do you tie failures back into the actual cause of the failure? So can you elaborate on that a little bit, please?
Yeah, certainly. So we are talking about heterogeneous integration. We are talking about multiple functional blocks getting integrated within the package. So the traditional view that we've had with functional test and generating functional vectors for individual die, that content, when things come together, that content needs to be redistributed. There are some interdependencies between functional blocks. Certain aspects are not directly observable, and certain aspects are directly observable. So if you look at the overall test flow, the content needs to be redistributed. Some of the content that has been important in the past in a single chip format may have to be re-architected or may need to be executed slightly differently, or the order of execution might be different. These are the types of things that a typical architect has to go look at. A test architect has to go look at, or in the case of Amkor, having the knowledge of integrating, and this is where the OSAT picture comes in. From a typical OSAT standpoint, we look at various examples coming from a large spectrum of customers. So we have to look at, we have some experience looking at from a test development standpoint, content distribution standpoint, functional test, what is functional test, and how much functional test needs to be from a test economic standpoint, how much SLT content would be right, and how much the overall coverage for test there is, and is that adequate, and where the importance and priority of the content needs to be. So these are the various aspects that the team needs to be looking at.
Understood. And that's great for the, let's say, the DFT functional side. And now, can you talk a little bit more about, you talked about how SLT is important. So the question is, there's a bunch of questions from the audience on this. I mean, one of the first ones is, how do you diagnose an SLT failure? Yeah. I mean, because it's typically much more generalized than a specific vector failing in DFT.
Yeah. I will definitely dance around the problem. This is a burning question for a large fraction of us. So how do you detect failures as the complexity increases? Again, this is where that plug for standardization, this is where that plug for DFT comes in. As the access to various functional blocks becomes complicated, we must simplify the problem by adding observability to each of the functional blocks that is important in the end application, in the end environment. So that's what one needs to take care of. So again, I'm not quite answering the question purposefully. This really depends on the specific example and the specific application. But over the past years, recent years, we've seen a huge increase in complexity, huge increase in the variety of implementations. So, large variation. Now we are at a point in the industry where we need to converge back and create some standardization in that large variety.
Okay, I understood the reasons for not getting more specific. But people are wondering, and if you can comment on it, with the increase in SLT testing, have you been able to decrease the amount or the how extensive the final test is occurring? So you've talked about reallocating where the test goes. So now the devices may be spending more time on SLT. So do you reduce the amount of time in functional test or final test?
Excellent question, Ira. Yes, as I said on one of the slides, content is getting redistributed. So, and everyone is conscious about test time and the amount of test cost. And so, yes, if a particular function is getting tested within the SLT test content, we certainly do not need that content any longer at functional test or structural test steps or weeding out manufacturing failures with structural tests. So yes, duplication is definitely not something that anyone would like to do, and we are seeing a few examples of those, but far fewer for sure.
Okay, and then you touched upon, thank you. You touched upon platform level test quality. Would you like to explain that a little bit more for people who aren't familiar with that concept?
The concept has to do, without going into much detail here, the concept has to do with maintaining quality and reliability with the end product. So various DPM metric goals that have to be achieved for a combination now, not just a single chip within the package, but we are talking multiple chips. And one of my earlier slides went into a stack of HBM memory or a couple of different logic die within the package. Those examples are becoming very popular. And so the quality metric goals are extremely important. I'm sure if there are more questions around quality, etc., I'd field them separately as well. So feel free to, my email is here on the screen. Please feel free to send me questions.
Thank you, Vineet. It looks like we've covered all the questions. So thank you for an excellent presentation. And once again, I'd like to thank the sponsors, our diamond sponsor, Amkor, with differentiators in technology, quality, and service. And our emerald sponsor, Advantest, receiving the highest ratings for customer satisfaction from the VLSI survey for 2 consecutive years. I would like to thank both of them for sponsoring today's event and tomorrow's event and sponsoring the Road Chiplets series. And with that, I will wish everybody a good day and look forward to having you join us again tomorrow. Thank you.